of the display. First of all, this is used by using persistence of vision. This display is on, after that this and that, this and this. This appears to be continuous to the viewer. Now we have interfacing of ADC, that is analog to digital converter with 8051. Analog to digital converter. Both parallel and serial ADC chips are available. Analog to digital converters are among the most widely used devices for data acquisition. A physical quantity is converted to electrical signal using a device called a transducer. In parallel ADC, we have 8 or more pins dedicated to bringing out the binary data. The higher resolution analog to digital converter provides a smaller step size, where step size is the smallest change that can be detected by an analog to digital converter. Here this is the ADC0804 chip. Here we will discuss about the various pins of this ADC. Here first of all, it is an 8-bit parallel ADC. It works with positive 5 volts. This VCC pin is used for positive 5 volt. It has 8-bit resolution. After that, we have these V in positive and V in negative. These are differential analog inputs. Often V in negative is connected to the ground and V in positive is used as the analog input. It is used as analog input to be converted to digital. After that, VCC is connected with positive 5 volt. It is also used as a reference voltage. It is also used as reference voltage when V reference over 2 is open. When this pin number 9, V reference over 2 is open, then this is VCC is used as reference voltage. V reference over 2 pin number 9 is an input voltage used for the reference voltage. It is used for reference voltage. V reference over 2 pin is used to implement analog input voltages other than 0 to 5 volt. After that, we have clock in and clock R. Clock in is an input pin connected to an external clock source when an external clock is used for timing. When external clock is used for timing, this clock in is used. To use the internal clock generator, also called self clocking of the ADC 804, clock in and clock are connected to a capacitor and a resistor as shown in the figure. For self clocking, clock R and clock in is used with a resistor and a capacitor as shown in figure. After that, we have chip select. Chip select is active low and read is also active low. Read is an active low input signal. Read is used to get the converted data out of the ADC0804 chip. After that, we have write. Write is not a proper name. Its name must be start conversion. When is an active low input is used to inform the ADC that it starts the conversion. When write is made low, then ADC starts conversion. Then we have interrupt request. Interrupt is a better name. Its better name must be end of conversion. It is usually high. When this pin becomes low, it means end of conversion. Your data is converted into digital. Then read is made low and data is taken from this data bus. It has 8-bit data bus. After that, we have read and write timing diagram for ADC0804. Here chip select is made low for both read and write. First of all, this chip select is made low, write is made from low to high to start the conversion. After that, when conversion is complete, this interrupt request INTR pins go from high to low. It shows end of conversion, and then we give a low pulse to read, and chip select is also made low, and data is now available on data bus, that is D0 to D7. CS is set to low for both read and write pulses. Clock source for analog to digital converter. The speed at which an analog input is converted to the digital output depends upon the speed of clock input. Two ways of providing clock to the ADC804, that is number 1 self clocking and second is crystal 2 of 8051 microcontroller. Here is the diagram of interfacing ADC0804 with the 8051. Here we have used two ports, port 1 and port 2. Port 1 is connected to the data bus of the 804 ADC. Read pin is connected to port pin 2.5 and write to the port pin 2.6, and interrupt is connected to the port pin P2.7. Here analog data is given which is to be converted to the digital form. To convert analog data, first of all write is made low. From high to low, write is made low. It means your ADC starts conversion. When conversion is complete, your INTR pin, that is usually at high, goes low. When it goes low, your microprocessor is in loop to check the pin, interrupt pin, that is P2.7. When it becomes low, then it makes its read of ADC low. Pin 2.5 is made low to read the data. Then the data which is converted in digital form is available on the pins D0 to D7 and is get into the 8051 through the data bus through port 1. Here VCC is connected to the positive 5 volt, and for self clocking it is in self clocking mode. Here register 10K, register of 10K and your capacitor of 150 picofarad is used with the pins clock R and clock in. V reference is connected with 1.28 volt. V in is grounded, analog ground, and we have this ground and chip select, they all are grounded to make them low. Then V in is used as analog input, that is given through this variable voltage source. Here this is the connection for 8051 to ADC0804 with clock from crystal 2 of 8051. Here we have used 4 to 5 D flip flops to obtain the correct frequency for the ADC. Each D flip flop divides the frequency by 2. When we connect Q bar to the D, then this divides the frequency by 2. Now we have interfacing of DAC, digital to analog converter, with 8051. There are two methods of creating a DAC, digital to analog converter, binary weighted and R to R ladder. The integrated circuit digital to analog converter use the R to R method. The number of data bit input decide the resolution of digital to analog converter. The number of analog output level is equal to 2, that is 2 raised to power n, where n is the number of data bit inputs. An 8 input DAC 080 provides 256 discrete voltage levels of output. The digital inputs are converted to current, and by connecting a resistor to the current pin, we convert the result to voltage. Here is the 8051 connections of digital to analog converter, that is 808. Here the digital data from 8051 is given to the digital to analog converter with the help of the port 1. Port 1 is connected to data bus of the digital to analog converter. Here the signals, that is the data that which is available, is converted into analog form, and it is isolated with the help of this operational amplifier 741, and a feedback register of 5K is used. And I reference current output is isolated by connecting it to an operational amplifier 741 with feedback register, that is 5 kilo ohms for feedback. We can monitor the output on the scope. Now we have interfacing of sensor, that is temperature sensor with 8051. Temperature sensors. Transducers convert physical data such as temperature, light intensity, flow and speed to electrical signals. Temperature is converted to electrical signal using a transducer called thermistor. LM34 and LM35 temperature sensors are used. The LM34 series are internally calibrated and is linearly proportional to Fahrenheit temperature. The LM35 series are internally calibrated and is linearly proportional to Celsius temperature. This is the flow chart for interfacing a sensor to the microcontroller. Here the analog word, here all the quantities are in the analog form. To connect a sensor, first of all we require a transducer. Here transducer converts this physical quantity into some electrical form. Now signal conditioning is required. Signal conditioning is widely used in the world of data acquisition. The most common transducers produce an output in the form of voltage, current, charge, capacitance, resistance, etc. However, we need to convert these signals to voltage in order to send input to the analog to digital converter. This conversion is called signal conditioning. Then we require ADC. Any ADC can be as 0808 or any other can be used. Here we have used 0848 ADC. Then we send that to the microcontroller. This is the circuit diagram for interfacing ADC0848 with temperature sensor. Here the temperature sensor LM35 or LM34 is used. Other connection is similar to the ADC080. Here this read pin is connected to the P2.5, write is connected to the P2.6, and then data bus is connected to the port 1. After that chip select is connected to P2.4 and interrupt. Here interrupt means end of conversion, write means to start conversion, and read is used to read the data when it is converted. First of all, we make write signal low. When it becomes low, then conversion start. Analog signal that is sensed by this temperature sensor starts converting into digital form. When this conversion is complete, this INTR, which is usually high, goes low. Microcontroller is in loop with this INTR pin. As this pin becomes low, microcontroller sends a signal that is read. Read is made low to read the data from the analog to digital converter. Here this figure shows the connection of a temperature sensor to ADC0848. We use LM336 2.5 Zener diode to fix the voltage across 10K pot at 2.5 volt in to overcome any fluctuations in power supply. V out of ADC 0848 corresponds directly to the temperature as monitored by this LM35 or LM34. Thanks.